Question 10, 2021 is a Bernoulli trial, as was question 1. We're told here 8% of the population have O negative. Find the probability that the 10th person is the third O negative donor. So we're looking at what happens in the first 9. If the 10th person is the third O negative, there's been 2 in the first 9. So we say 9 choose 2. 9 by 8 over 2 by 1. And we're going to multiply that by the probability of success. So the probability of success is 0.08. There's been 2 of them. We're going to have to multiply that by the probability of failure, which is 0.92, and there's been 7 of them. 7 and 2 is 9. The powers always add up to this number here. And this number is always this number, if you know your Bernoullis. And then we multiply what's happening on the 10th, which is success, third O negative, 0.08. So just calculate our use for this one. That gives me 0.01028, 0.01028, 4 decimal places again, 1, 2, 3, 4, so 0.103 here, 0.0103, so 1% chance in part A here. Part 2, 5 donors give blood. What's the probability at least one of the 5 donates O negative? And once you see at least 1, it's 1 minus the probability of none, because every other probability other than none will be at least 1. So we just need to find the probability of none here, which, if you wanted to write as a Bernoulli trial, we have 5, none of them are O negative, 0.08 to the power of 0, by 0.92 to the power of 5. These two are equal to 1. So it's just 0.92 to the power of 5 here, which is equal to, that's equal to 0.659. There's a 0, but we're looking for 4 decimal places, so I'll go 0.8 and I'll round that to 0.6591. So this is the probability of none. So 1 minus this probability would be 3409, 0.3409, correct to 4 decimal places. Find the minimum number of blood donors required, so the probability at least 1. So again, 1 minus the probability of none, 1 minus the probability of none has to be greater than 0.97. So 1 minus 0.92 to the power of 5 is what we had. Has to be greater than 0.97. So we're not looking at the 5, we're looking at n in this case. To solve for n, the minimum number of blood donors required so that this probability is greater than 0.97. So tidy it up, we can multiply by by minus 1 and say 0.92 to the power of n. We'd have to reverse the sign, and that would become 0.03, and then we're going to have to reverse the inequality again when we divide by n times the log of 0.92, which will be less than 1, so we'll have to reverse that inequality again, just getting the log of both sides. So n is going to be greater than the log of 0.03 divided by the log of 0.092. So n has to be greater than, that says n has to be greater than 42.05. So n will be equal to 43. So why don't we put that in? 1 minus 0.92 to the power of 43. That's going to give me 0.9722, 0.9722. So may as well check 42. 1 minus 0.92 to the power of 42 is going to give us 0.9698, 0.9698. So you can check to see that you're right here in this exam. 43 is the correct answer. Part B. homeowner has a problem with a heating system. A plumber has identified the problem as a faulty part. The homeowner, tongue twister, knows that in 80% of cases, a repair of the part will fix the problem, and this will cost 70. So in 80% of the cases, it's going to cost you 70. If the repair does not work, a new part will have to be bought, costing 150, and there will be an additional labor cost of 80 to replace the old part with the new. Find the expected value. So we're dealing with an expected value question. We can do a pie chart. There's two things that can happen here. We don't need to worry about the angle. This is just a sketch. So this is your 70 euros, and this is 80% of the time, and this guy is 20% of the time. And what happens in here? So what happens in here is the repair doesn't work, so the repair is 70. The new part will have to be bought, costing 150. So now we're up to 220. We have 70 we have to pay, the 150, and an additional labor of 80 is going to be 300. So in 20% of the cases, you're going to pay 300 euros. So the expected value here is 70 by 0.8. 8 sevens are 56, and 300 by 0.2, which is 60 and 56. The expected cost here, the expected value of this, is 116 euro. Part C, an insurance policy pays out 120,000 on debt, 40,000 if the holder becomes disabled. The insurance company has calculated in general any given year probability of death 0 with 3 zeros. The probability of death, a bit of a morbid question to end the 2021 exam. 0.0001 is the probability of death, and the probability of disability, they couldn't have made this any other type of question. 2 zeros up and not 2 for disability. The company has 18,000 policyholders who are all charged the same premium. The company's goal is to make 900,000 profit in a particular year. Find the annual premium it should charge its customers, which in an average year would generate this level of profit. So of these 18,000, how many of them are going to die is what we actually have to think here. Not one of them are going to die. And of these 18,000, some of them are going to become disabled. 0.002 of them are going to become disabled. So 1.8 of them are going to die, and 36 of them are going to become disabled. So how much are they going to have to pay out? Now we're dealing in on average here in the long run. So 120,000 we're going to have to pay out 1.8 times, and 120,000 by 1.8 is 216,000 on average. They're going to have to pay out 40,000 to the 36 people that have become disabled, and 40,000 by 36, 436 is 144, so that's 1440 to the disabled people, giving a grand payout of 1,656,000. So they have to generate 900,000 profit. So the premium has to bring in 900,000 more than they're going to have to pay out. So it's going to be 2556. So 2556, we just have to divide by the 18,000 policyholders to get how much they're all going to pay. And that will be 142 euro.